Hello everyone, welcome back to my channel. I am Kashmira Hazra Das Gupta. Today we are going to start a new course on automation and I have named it as Automation World. Now you know this that today's industrial world is revolving around automation. So as an electrical or electronics or mechanical engineer, having a sound knowledge on automation can help you fetch a good job in any industry. And even as a student, this automation will help you in making a very good project as your final year project or your mini project, anything. So without wasting much time, let's begin. What is automation? This word is basically divided into two parts. Automatic plus operation, that is automation. So automation is your automatic control, right? It is the use of control systems for operating any equipment. Example, it can be used for any machinery. It can be used in process industries, in food processing industries. It can be used in boilers, heat treating ovens, steering and stabilizing of ships, aircraft, also in vehicles with least or reduced human. Now let's come to the definition. Automation is the delegation of human control system to the technical equipment. In simpler words, it is a technique or a method or any system that operates or controls a process by highly automatic means, as by electronic devices, reducing human interventions to minimum. Now let's see the advantages. It reduces the production time, it reduces the manpower, it improves the quality of your product, it improves accuracy, it improves efficiency, and definitely it increases the safety standards in an industry. Now let's see the components of automation. Now this is an example. Let's suppose this is a conveyor belt and these are bottles. Have you seen a bottle filling plant? You may not have seen it personally, but you have seen it in a TV or computer, the videos, right? So let me explain. So consider this as your conveyor belt and these are your bottles that are moving over here. So what are the things that are connected? There's a motor that helps the conveyor belt in moving. There's a drive. This drive is used for speed control of the motor. Then there's a PLC, programmable logic controller. Then there is HMI connected, which is human machine interface. Then there is control room or SCADA. In the control room, they are controlling it using SCADA. The full form for SCADA is supervisory control and data acquisition. So we will be studying each and every component individually in the coming course. Let's see the components of automation. There are field instruments, that is your sensors, your transducers, etc. Then there are control hardwares. Then there's a control system, your PLC. And then last but not the least are your output elements. Now PLC, that is programmable logic controller. The first PLC was developed in the year 1969 by Modicon Company. Richard E. Morley is known as the father of PLC. He is the first one to make PLC. This company is now acquired by Schneider. Remember that the father of PLC is Richard E. Morley. This is very important. Now let's come to the definition part. It is a solid state device which takes input from field, process it according to predefined instructions and then gives the output. Now I'm going to explain it in simpler words. Okay. So what do you mean by solid state device? Solid state refers to electronic devices, components and systems that are based entirely on semiconductors. Okay. So your PLC, it is a computer control system used in industry that reads your input, then makes decision based upon the customized program that you have already made to control the output devices. Okay, I hope this is clear. Now let's move on. Now input and output of your PLC are divided into two parts. One is your analog, the second one is digital. In case of analog, the inputs are like RTD, which is resistance temperature detector. It can be a thermocouple, a thermistor, pressure gauge, etc. Now for outputs, it can be a control valve, it can be an actuators, something like that. Now in case of digital, your inputs can be push button, toggle buttons or limit switches. And the outputs can be LED, a contactor, a relay, a solenoid, etc. Now let's come to the block diagram part. Now as we have already discussed the components of PLC, so let's see it in block diagram. We have an input module, a CPU, an output module, and the most important, a power supply. The power supply provided to your CPU is 5 volt DC, and the power supply provided to your input is 24 volt DC, and output is also 24 volt DC. So let's jot down the components. An input module, a CPU, an output module, power supply, and fifth is your communication unit, that is your PC to your PLC connection. Okay, there are three types of PLCs. One is non-modular, that is compact type. All the components are built in the same base here. You cannot remove it. Now modular. All the parts have different sections here, that is expandable. It is again divided into two parts. One is rack, the other one is rail. I will show you the pictures of the different types of PLC later on when we start reading about each PLC. So don't worry, I'm just giving a brief introduction here. And the third one is compact plus modular, that is fixed plus expandable, a combination of both the two PLCs. The companies that manufacture PLC. These are the few companies, there are a lot more. Allen Bradley, this is the most important and most commonly used PLC. It's an USA based company. Then there is Siemens, it's a German company. Then there's Omron and Mitsubishi, these are Japanese companies. Misung, it's an Indian company. Programming language that we use in PLC. The first one is ladder language. This is the most common language that we use. In fact, this is the programs that we are going to study in the coming course are based on ladder language. Then there are STL, statement list. Then ST, that is structured text list. Then there are instruction list. Then function block diagram. Then sequential flow chart. So now let's see what is scan cycle and scan time. So your scan cycle, it follows three parts. One is input, that is read the input first, then execute the program, and then updating your output. What is scan time? Time taken to cover one scan cycle is called as scan time. So it is normally between 10 milliseconds to 100 milliseconds. The lower the scan time, the better is your program. So this was a small introduction to automation. We will be studying more. The next topic that we are going to study is a PLC. I will be teaching you how to open Allen Bradley PLC, how to make programs and basic things about PLCs and basic things about Allen Bradley, and then we'll move on to the programming part. We will solve around 50 to 60 problems. So don't forget to subscribe to this channel and stay tuned for the next chapter. Thank you.